So in section 1.3, we're going to be talking about length and distance. So a first vocab is a coordinate, which is a real number assigned to a location on a number line. And to find that number, we're going to take the absolute value between the two endpoints. We're going to take the difference, and the answer is always going to be positive no matter what. Then when we're talking about congruence, it's when two or more segments have the same length or measurement, and we use this symbol right here to show that something is congruent. And then lastly, we have the measure of segment AB or AB. Again, that's the difference between the two endpoints. So we're going to look at a few examples here. So the first example is find the lengths of the given segments. So FA, so again, we're going to take the absolute value, the difference. So we're going to start with -3 minus -9. And that's going to turn out to be 6. So our answer is 6. You could also count, but we kind of want to do it more of the mathematical way. So for ST, same thing. We're going to do 7 minus -4. And that's going to give us 11. And then lastly, we have RT, which is going to be -3 minus 3, which that turns out to be -6, but since we're taking the absolute value and distance cannot be negative, it becomes a +6. And then another thing to remember when doing absolute value and labeling distance in segments is when two segments have the same length, we label them differently. So if a segment is a geometric figure, so that's labeled AB with the segment symbol above. So that can be congruent. Length is labeled AB without the symbol above, and that can be equal. So we really want to focus on the difference between the congruent symbol and the equal symbol. So this statement right here says that segment AF is congruent to segment RT. And then if we look down here, we have that AF equals RT. So what that actually means in words is that the distance of A to F is equal to the distance of R to T, or that the length of AF is equal to the length of RT. Next, we have segment addition postulate. So when we have a point between two other points and they're all on the same line, then that means that the two segments, when you put together, will equal the longer segment. So for this example, we have PM plus NQ equals PQ. So the first step to solving the problem using segment addition is going to be to write down the equation. So our equation, I like to start writing it down in letters because it's easier for me to see what I'm going to plug in. So we're going to write Ln plus Mn equals Ln. So again, the two shorter segments equal the longer segment. And then we're just going to plug in from there. So Ln is 4x plus 6. Mn is 7x plus 15. And Ln they give us is 120. And we're trying to find Ln. So we're first going to have to figure out what x is and then plug that back in. So here we're going to combine like terms. We get 11x plus 21 equals 120. When we subtract the 21 over, we get 11x equals 99. When we divide by 11, we get that x equals 9. So here again, we're not done because the question asks us to find Ln. So we're going to take Ln, which is 4x plus 6, and we're going to plug in 9. So we're going to do 4 times 9 plus 6. So then the length of Ln is 42. Our next example, we're not given a picture, so we're going to have to draw a picture. So it says that B is between A and C. So I'm going to just start with a line. And I'm going to put B between A and C. And then it says AB is x squared, BC is 7x, and then AC is 18. So then we're going to write our equation. So with segment addition, we're going to do AB plus BC equals AC. and then we're gonna fill in accordingly. So AB is x squared, BC is 7x, and that's gonna equal the whole thing, which is AC, which is 18. Now, in order to solve this, we're going to have to factor. Since we have an x squared, we're going to get everything on one side, make it equal to 0. We're gonna factor and then see if the two answers we get make sense. So again, we're gonna subtract that 18 over, so we get x squared plus 7x minus 18 equals 0. So remember with factoring that we are looking for two numbers that multiply to be negative 18, but add to be 7. So our multiples of 18, we've got 6 and 3, we have 9 and 2. So right off the bat there, if you look, if we 9 and 2, we can get 7. So we want a positive 7, so we're going to take 9 minus 2. So that means we're going to have x plus 9 as one of our factors, and then x minus 2 as one of our factors, and still they equal 0. So if we go to solve them both, we've got x plus 9 equals 0, and x minus 2 equals 0. So our two solutions are x equals negative 9 and x equals 2. But again, if we think about our problem, if we go back up here, we plug in negative 9, 7 times negative 9, it does not make sense, again, to have a negative for a distance. So that means that we can get rid of negative 9. So when we're looking for BC, we're just going to do 7 times 2. So BC is going to equal 14. And then lastly, what does it mean to be in the middle? So we're going to do a lot with midpoints or bisecting. So bisect means to cut into two equal parts. And a point, line, ray, or other segment that intersects another segment at the midpoint is called a segment bisector. So if we look here, we've got that B is the midpoint of AC, and line L is cutting through that line, so that is a bisector of AC. And then if you look here, we have two tick marks here. So those tick marks show us that segment AB is congruent to segment BC. Also that AB equals BC. So when we're doing equations, if we see those tick marks and we have equations above them, or something's in the midpoint, then we can just set those equations equal to each other, since we know that those segments are congruent, therefore they're going to end up being equal. So same thing as yesterday. If you have any questions, go ahead, write those on the side, and then you're going to complete the 1-3 worksheet and write down any questions you have as you go through that.